prove that root 2 is irrational. So to do that, the first thing we can do is to assume the contradictory thing that root 2 is rational. So assume that root 2 is rational. So then, or I can say then root 2, so then we write root 2 equals P out of Q, where P and Q are non-zero integers and they do not have any common factor other than 1. So that's the condition for P and Q. So now what happens if we square both sides? Squaring both sides, so squaring both sides, so we'll have, if you're squaring both sides, then you'd have root 2 square equals P out of Q square. So you get 2 equals P square out of Q square. And therefore, what happens is 2Q, not, yeah, of course, sorry, 2Q square equals P square. Now when you write 2Q square equals P square, then P square is even because it's a multiple of 2. And if P square is even, P must also be even. Okay, therefore P must also be even. So it's a must. If P square is even, P has to be even, you know. So then what happens is, so you see, if P square is even, so we can write P square as, say, 2k. So if P square is even, so let us write, so we say let us write P square equals 2k, where k is some integer or any integer, you know, where k is any integer. So if k is any integer, we can write P square is 2k because P square is even. So what happens now to 2q square? So you see, if P square is 2k, no, sorry, we don't need, so we can write, instead of writing P square, I think we need to write P is 2k, because P square 2k, because then we can do the square of that, because ultimately we have to prove it by contradiction, saying what we have said before is incorrect. So if we say P equals 2k, see, then it's going somewhere. So let us write P equals 2k, where k is some integer. So therefore P square, it would be 4k square. So if we use 4k square equals here instead of P square, so therefore we can write 2q square equals 4k square. See, now it's going somewhere. So 2q square equals 4k square, and therefore q square equals 2k square. So q square is even, and then q must also be even. So what we see here is we are saying now that Q must be even, and we have said P must also be even. So if P and Q are both even, then they have a common factor other than 1, which is 2. So therefore P and Q will have a common factor other than 1, which is 2, because they are both even. So this is a contradiction. This is a contradiction, okay? This is a contradiction. Hence, P and Q. So if root 2 cannot be written as P out of Q, so hence, root 2 cannot be equal to P out of Q, because then everything. So therefore root 2 is irrational, because any rational number can be expressed in the form P out of Q, where P and Q could be any integer, but Q is of course not equal to 0. So root 2 therefore is rational and proved. Irrational, proved. Thank you so much for watching, and if you find the video useful, please subscribe. Thank you very much.